Hello, good morning, and thank you for joining Kuiper and VMware for day 3 of our Big Breakfast series. Hopefully, like me, you've all got a mug of tea or coffee on the go, or if you felt adventurous this morning, been inspired by the image on screen and gone the full English. I'm Stuart Hall and I'm Director of Kuiper. Today, I'm joined by my colleague and Head of Sales, Neil Jelly, plus joining us all week are 2 VIPs from VMware. I'd like to start off these sessions by explaining a question we get asked a lot. How did you ever decide on the name of Kuiper for your company? For those of you who've been on our past 2 sessions, you will know the answer. But for those new to our webinar series, the answer is that our company name relates to the Kuiper belt in space, which encompasses much of the universe as we know it. Our mantra is that we are universally embracing IT solutions by acting as a broadline provider in every aspect of IT. So this fits very nicely with the fact that we help our customers with everything from standard hardware and software, right through to telecoms, managed services, and more recently, digital signage. We've worked hand in hand with VMware for many years. Their portfolio has gone from strength to strength, and as they've expanded, we found that our customers benefit greatly by building upon their existing investments by taking advantage of what VMware has to offer. This series is all about trying to answer the questions that our customers most frequently ask, and thrilled that VMware are with us today to help answer them. Today's session is the 3rd in the series. We'll be sharing details on the other sessions at the end, all of which will be available on demand. To give you a bit of variety, I'm now going to hand over to Neil to ask today's big breakfast, big question. Over to you, Neil.
Thanks, Stuart, and good morning, everyone. Today, we're asking the question, how can we stop users from taking unnecessary risks without impacting performance? So why do we need to ask this question? Well, as no doubt some of you will have experienced, a user's error can turn into your problem, especially when they're using non-approved and unauthorized apps as a workaround for sharing info. This becomes an even bigger problem when employees can't access the apps they need from a remote location. Fortunately, VMware has developed Horizon, which makes Windows apps securely available to anyone on any device. So here to talk to you about it are 2 people I'm excited to introduce. Joining us today from VMware are Paul Whitton, End User Computing Solutions Engineer Manager for UK and Ireland, and Darren Hirons, Senior Solution Engineer for Digital Workspace. Over to you, gents.
Thanks, Neil. I'll start sharing. So yeah, as Neil said, I'm Darren Hirons, Senior Solutions Engineer at VMware, and welcome to day 3 of the Virtual Apps and Desktops session. For those that might not have seen it in the previous 2 days, I just want to quickly recap on what the Workspace ONE solution stack looks like. On day 1, we covered the access layer, the blue layer at the bottom, which typically encompasses all the bits that the end user will interact with. So like the app catalog and the single sign-on, the conditional access, etc. Yesterday, we moved into the green layer and looked at unified endpoint management, excuse me, and looked at all the ways that we can manage devices. We've touched at various times on the intelligence layer about how we can collect all this data and analytics and do intelligent actions on it. But today's content is all really focused on this Horizon layer. So we're looking at shared virtual desktops, published applications, Windows 10 and Linux VDI, etc., and how we manage all that as well and how we efficiently deliver it. So that's what we're going to focus on today. We did touch on the Assist add-on yesterday, which is how we do remote assistance for remote users. And we'll probably touch on the security add-on in tomorrow's session, which is the security session. So yeah, today's session is all going to be about virtual apps and desktops. As always, there's a glossary of terms in here, so if you get sent a copy of the slides afterwards, you can refer back to it. I'll try, as I have done the last 2 days, I'll try not to read out the acronyms. So let's first start off by a little quick learn session where we'll just review what exactly we mean by VDI or virtual desktop infrastructure and what we mean by RDSH, which is remote desktop session host. So I'll elaborate a bit more on these technologies. But before we do that, why are we even talking about Windows apps, right? We've talked about Chromebooks, we've talked about MacBooks, we've talked about all these different devices. Why have we got this whole session dedicated to Windows, right? Well, the answer is that Windows apps still make up a huge part of the enterprise market. So we're still looking at about 80% of all the apps used in enterprise today still run on Windows. So you've got efficiencies in switching those from physical Windows to virtual Windows, but you've also got the problem of how do you deliver these enterprise Windows apps to non-Windows devices? And that's, again, where Horizon can help. So in traditional end user computing, end users are given an Office PC, or it could be a laptop or some other type of Windows device, and they typically use that device on a one-to-one basis. Historically, people have often gone to the office, sat at the same desk every day, and used the same PC or laptop every day. When we switch that around and look at it from a virtual desktop point of view, it's largely the same, right? So people are still logging into a desktop. It just so happens that this is a virtual desktop now, it's not physical anymore. And there are lots of administrative and management efficiencies that come with switching that from physical to virtual. And we'll cover those off in today's session. But what's RDSH? What is this remote desktop session host? It's been around for a long time. It's actually a feature of Microsoft Server. And what it allows you to do is it allows you to share desktop sessions from a server operating system. So what this meant from a kind of VDI point of view is that end users could now access a desktop to all intents and purposes, but not on a one-to-one basis. We can do one-to-many. So this was a real sort of game changer a few years back, in that it was a much more efficient and a much more easier way to manage, because you only have to manage one server operating system to many employees. And obviously this can be scaled out in what we call farms, and you can deliver this to thousands and thousands of individuals. The other thing that you can do with a remote desktop session host is you can also deliver just the applications as well. So you don't even have to deliver a full Windows desktop session. You can actually deliver just the application in its own window. And this again has been popular over the years, so this is still very much used today. So let's move on and look at some options that exist in today's Horizon platform. So essentially, we have three options when it comes to deploying Horizon. We have the Horizon 8 platform, which can be deployed on premises or in a number of public clouds, and they are represented by the two green boxes. The on-premises version obviously resides in your own data center, or in your own data centers, plural. The public cloud version of Horizon 8 exists in many public clouds, such as VMware Cloud and AWS, Microsoft Azure VMware Solutions, Google Cloud VMware Engine, Oracle Cloud, IBM Cloud, just some examples, right? Moving on from Horizon 8, we also have a version called Horizon Cloud on Azure. Now, the significant difference around Horizon Cloud on Azure is it doesn't run on VMware infrastructure. It runs on Azure native infrastructure. So this is just a native Azure tenant, and we are layering Horizon on top of it. Then the last option on the right-hand side is what we refer to as Horizon Daas. So this is typically run, operated, managed by VMware partners. There are thousands of them all over the world that can deliver this as a managed service. Now, what you'll see is there's a banner along the top which says Horizon Cloud Control Plane, and it spans across the Horizon Cloud on Azure, and it also spans across the Horizon 8. What this means is that we can manage all these environments from a single portal. So we've got one single pane of glass to be able to manage all these different desktop infrastructures, even in a hybrid environment where some of it might be on-prem, some of it might be in Google Cloud VMware Engine, some of it might be in Azure, for example. So what about licensing? How are these licensed? So this has changed recently. So if you now want to deploy Horizon 8 on premises, we have a new license type called a Horizon Terms subscription. But that effectively is the same as the old perpetual license. You can run it on-prem. It has no dependency on the cloud whatsoever. If you want to run Horizon 8 on premises and you want the cloud control plane functions, like maybe you want to do a hybrid approach, or if you're running Horizon 8 on any of the public clouds, then you need the Horizon Universal license. The fantastic thing about the Horizon Universal license is that Horizon license is portable. So you can pick it up at any time and you can move it to a different platform. You could split it up, you could take half to a different public cloud and leave half where it is. You can basically move it around as and when you like, and there are no limitations to how often you can do that. The Horizon Universal license also covers Horizon Cloud and Azure as well. So you could, for example, deploy your desktops on premises, and then in 12 months' time, you could decide to pick them up and move them to Horizon Cloud and Azure. And you can still use the same Horizon Universal subscription to do that. Again, going back to the Horizon Daas solution on the right, that's typically partner managed. So there's no VMware licensing as such with that. It's delivered through a partner. Let's take a bit more of a look at the actual components and how Horizon 8 actually works. So we have various components and various editions of Horizon when it comes to the running this on premises. We have a standard, advanced, and an enterprise SKU. The standard version includes all the underlying SDDC infrastructure, so it comes with all the vSphere licenses you'll need, all the vCenter licenses you'll need. It comes with the capabilities of using our protocols, which are BLAST and PC over IP. It now includes the instant clones technology, which we're going to talk a bit more on later today. It includes a reduced feature set version of Dynamic Environment Manager. More about that later as well. It includes ThinApp. It includes the ability to broker physical desktops, and it includes the ability to deliver VDI desktops. So these are Windows 10 desktops. Moving into the advanced stack, this gives us the ability to do Skype and Teams optimization, which is a big feature request right now that everybody's starting to use, especially with everybody being working remotely. We can deliver virtual apps, like I just showed you in the RDSH slide. We can deliver those published applications out to end users. And we can do those shared RDSH desktops as well through the Windows Server operating system. Moving into the enterprise stack, we've got an enterprise version, a more feature-rich version of Dynamic Environment Manager. We've got app volumes, which allows us to do application layering. And then we've got things like session collaboration, the help desk tool. We can also do Linux desktops, and we got full access to the API. So the enterprise version is really the version that contains all the features. And if you buy that through the universal license, you get the ability, as I said before, to run that on any cloud. So looking at the Horizon 8 term-based license, as I mentioned, this is for use on premises only. So all the licensing, all the management, and all the brokering is done on premises through our management interface. It always runs on VMware SDDC infrastructure, which, as I said before, is included in the license. And that can include VMware Cloud Foundation. And it always runs on premises. So that's the term-based license. This SDDC infrastructure is typically spun up in your data center, and you'll deploy and create these VDI desktops on that infrastructure, and they will, there'll be Windows 10 or Linux desktops that'll sit there waiting for somebody to log in. Your users come along with a client device, which can be any kind of device, as Neil said earlier. You can come along with any kind of device as long as it's got a web browser or a Horizon client installed. And you can connect into the Horizon platform, and that will broker your connection and give you access to a desktop through a secure tunnel. As I mentioned a few minutes ago, we can also use Horizon 8 to broker access to physical PCs. And this was in huge demand when the pandemic first hit, because lots of companies had staff that were sent home for obvious reasons, but they still had lots and lots of kit sat on desks, lots of desktops on desks that they couldn't get to, and therefore they couldn't use. So what we were able to do with Horizon is we were able to quickly and easily spin up a Horizon instance, and we were easily able to allow those home users with personal devices to get access to the same desktops they used to use in the office. So just keep in mind that we can also use it for that use case as well. Now we're going to switch our attention to going a bit deeper into Horizon, and we're going to look at what we call the JUMP platform, or you might see it written as the JMP platform. Essentially, JUMP stands for Just-in-Time Management Platform. And this is how we manage and efficiently create these desktop operating systems. Now, when VDI first came out many years ago, it was only in the format of what we call a persistent desktop. So it was very much like a physical desktop in that an end user would log in, they would make changes, they might change the wallpaper to a picture of their family, for example. They'll install some applications, they'll log out. The next time they'll log in, everything is exactly as they left it because they've got exactly the same desktop. And from an end user experience point of view, persistent desktops are fantastic because they give the same experience as a physical desktop. However, from an administrative point of view, they're a bit of a nightmare because you have to manage them exactly the same as a physical endpoint, so you lose a lot of the VDI efficiencies. You also have to leave them turned on all the time in case somebody wants to log in. You can't ever delete them, so they always consume disk space. So there's some management and administrative overheads to running persistent desktops. So after a few years of VDI being available, we started to see non-persistent desktops arrive. Now, non-persistent desktops are exactly the opposite. Every time a user logs in, they get given a brand new fresh desktop, which is fantastic for IT because they never have machines that are just sat there doing nothing. They don't have to maintain machines like in physical estate. But from an end user point of view, they're not a great user experience because an end user can't change anything and have any persistence in that session. They'll change the wallpaper to a picture of their family, they might install some apps, they'd log off and log back on again, and it would all be deleted. So what we've been trying to do over the last few years at VMware in the Horizon platform is we've been able to try and unify these two platforms and create what we call the truly stateless desktop, which gives all the end user experience benefits of the persistent desktop, but really we're delivering a non-persistent desktop. So it's got all the administrative and management efficiencies. And this is what we're using the JUMP platform to try and create. So there are three elements of the JUMP platform. There are instant clones, which actually creates the desktops. We've got app volumes, which does the application layering. And we've got dynamic environment manager, which controls the profile and the personalization of those end users. And what we're really doing with the just-in-time management platform is we're separating out these layers. So we're no longer giving somebody a desktop where all the apps, all the OS and all the apps and all the settings are all trapped inside one layer. We're separating them out so that we can redeliver them dynamically. So what the flow looks like now when you're using the just-in-time management platform is that a user will log into a virtual desktop. Instant clones will create that virtual desktop. Now, the instant clone process runs inside the VMware hypervisor. It has no external moving parts, so it's all done inside the hypervisor. It can create a running virtual desktop in under a second, so it's very, very fast. That's a unique desktop. It's already added to the domain. It's got a unique name, etc., etc. So to all intents and purposes, it is a new unique desktop. That desktop typically will have not too much installed in it. It'll be quite vanilla. So we're trying to separate out these layers. So we want to keep it as vanilla as possible. But it will have some agents installed in it, and we'll discuss that as we go through this slide. So they get access to this new desktop, and it is a brand new desktop. As they log in, the app volumes agent in step 2 will look who the user is that's logging in, and it will look up in its database what applications that user is entitled to. It will then layer on the applications on top of the desktop that user is entitled to. And we'll discuss how it does that in a second. Step 3 is it will also layer on top their personalization. So anything that they customized in their previous session, did they set up a new printer? Did they change their wallpaper? Did they add some desktop icons? All those kinds of things that we take for granted in a persistent desktop. It reapplies all those to this new desktop. The end user then can use that desktop for however long they're logged in for their session time. They can make customizations to that desktop. They then log out at the end of that session, and everything that they changed during that session gets saved away in the settings layer, and the desktop gets destroyed. So these desktops are only ever used once. The next time the end user logs in, they go right back to the beginning of this cycle. So this has lots and lots of efficiencies, right? So the desktop's never going to get old, it's never going to get stale. If one user logs in and causes some issues with the desktop, they're not going to persist to the next person that logs in. Every time someone logs in, it is a brand new Windows desktop. Also, this can help reduce service desk tickets as well, because if everybody's getting a brand new desktop every time, there's a lot less to go wrong. So we're using these three technologies in that cycle you just saw to be able to separate out those layers and deliver those dynamically. Let's focus a little bit more on how each one of them works. So let's start with instant clones. So instant clones, as I said, runs inside the VMware hypervisor. What we do first is we create what we call a gold image. That gold image is like a master of what we want all the desktops to represent. So it's got all the necessary patches in it. It'll have all the necessary agents installed. You might choose to put some software in there, but you might not put all your applications in there. What happens in the instant clone process when you create a desktop pool is that that gold image creates what we call a parent on each host in the cluster. And then from that from that parent machine, we use the instant clone process to create the virtual desktops. So this VM fork process is what creates those desktops in around about a second. And we can spin up literally thousands of desktops in a really short space of time. Once those desktops are created, obviously, end users can start logging onto them. And when you want to be able to update an instant clone desktop, this is a really good process as well. The main benefit, I would say, is that end users will never be interrupted by any patching processes. So end users will never get that message, that dreaded message when you're in the middle of something important, which says your machine needs to reboot for an emergency patch, or you need to reboot to apply some patches, and you've deferred it so many times it won't let you defer it again. So what happens with instant clones during an update process is you make your changes to the master image. The gold image is the only machine you ever change. So you can power on that gold image while the desktop pool's in use, and you can make whatever changes you want to it. You could install some new apps in it, you could take some apps off, you can install the monthly Microsoft patches from Patch Tuesday. You can do whatever you like with that image. Once you've done it, you create a new snapshot on it, and you initiate what's called a push command, which then pushes the master image and updates each one of the parents. Once the parents are updated, all we have to do is wait for each user to log off and log back on again, and their desktop gets recreated from the updated parent machine. So if you have a policy, for example, which mandates that all your users have to log off and log on every day, they have a maximum period they can stay logged on for, then you can guarantee that your entire estate of desktops are going to be patched within 24 hours, for example. And they've had all this with no interruption to their session, asking them to reboot for patching. Let's move on now. Let's have a quick look at the app volumes and how that works. So when we look at the components of a virtual machine, we're really talking about a hardware layer, a virtual machine, and a hard disk. That hard disk is typically referred to as a VMDK. And all we're doing with app volumes is we're installing those applications inside a VMDK. So effectively, we're putting the applications inside a virtual hard disk. When that end user logs onto a desktop and the agent sees that that end user needs to have an application assigned, what it's doing behind the scenes is it's attaching a virtual hard disk to that person's virtual desktop. When the agent that's installed in that operating system sees that virtual disk, it hides it and makes it look like it's all part of the operating system. And it does this by reading all the files and registry changes on that disk, and it merges them in with its own hard disk. So when an end user looks inside add remove programs, or goes into Windows Explorer and looks in the program files area, or looks in the registry, for example, all these applications will look and feel as if they're installed already, when really they're being dynamically layered at the point of login. So what happens is end users log into their virtual desktops, and depending on what applications they're entitled to, those applications will be layered onto their desktop during the login. Now, all this is done during the login. They don't have to wait for them to appear after they've logged in. Because they've been attached by a virtual disk, there's nothing being streamed over the network. So we're not being dependent on the speed at which something can be streamed over the network. We're simply attaching something. So think of it like plugging a USB drive into your PC. The contents of that drive appear straight away. That's essentially what we're doing with app volumes. So once an end user's logged in and the desktop's usable, the applications are already there. They can click on the start menu, they can see all the icons, and they're already usable. So again, we're giving that user the feeling that they've got a persistent desktop from an app's point of view. Within app volumes, we also have a feature called writable volumes. Now, the idea of writable volumes is that this is a VMDK that follows the end user around, and it can cache anything that the user writes to the virtual machine during that session. So an end user might log on and they might be given some application in the form of app stacks, like we showed on the previous slide. They may also be allocated a writable volume. And we typically see these being used for things like Outlook cache files and PSTs. So, if you've got an Outlook cache file, an OST file, and your machine gets deleted when you log off, you would be in a situation where you would have to start resyncing your mailbox every time you logged in, and nobody wants that. It's a terrible user experience. So we can use the writable volume to cache the OST file, for example. We can also use it to cache things like OneDrive content. And so when an end user logs on, they get their apps that they're entitled to, and they might also get assigned a writable volume. Now, if those end users have got admin rights, they can even have the capability to install their own applications as well. And when those applications are installed, they're actually written to the writable volume. Therefore, when an end user logs off and logs back on again, and their app stacks get reattached and their writable volume gets reattached, the applications that they installed in their previous sessions reappear as well. So it makes application installations persistent as well. Let's move on to the final layer now and talk about the settings layer, which we control with Dynamic Environment Manager. So typically the settings for an application and the settings for the operating system are tightly coupled within the operating system itself. What we're doing is we're splitting those out, and we're able to control the application configuration, the user environment settings, and any personalization the end user does, and abstract it away and put it into this settings layer. Now, typically this settings layer can exist on a file share somewhere. It's just abstracted away and saved somewhere. So what this means now is that somebody's logged on with an instant clone desktop. They've been allocated their applications that have been layered on. All we're doing is reattaching all their settings and all their personalization and app config. So an example of this could be something like this. So an end user logs onto an iPad and they launch a published application version of Word. Doesn't have to be a full virtual desktop. It can just be a published app. When they're in that session, they might customize the app. This might be something simple like turning on the navigation sidebar. Once they turn on the navigation sidebar, they might finish what they're doing and they might disconnect. Those settings will get saved back to their settings layer, and that end user later on that day might go and sign on to their desktop, or it might be a virtual desktop. When they launch a version of Word within their virtual desktop, it'll go back to their settings layer and it will recall the settings that they last saved, therefore replaying and assigning the navigation sidebar. So this is how we can get application persistence between sessions. And there are lots of benefits to using Dynamic Environment Manager. So we can make those settings for applications persistent between sessions and between virtual desktops and virtual applications. We can even allow users to change the settings of an application, but we can always reset them back if you wanted to do that. All the settings for an application are imported at the point of launch. They're not imported during the logon process, which typically happens with the physical Windows desktop. This means we can use Dynamic Environment Manager to speed up the login process as well, because when we're taking some of the bits that are done during login and doing them afterwards. These settings as well, they're persistent between different versions of Windows. So, if you've got different if you've got a user that uses different devices and they're on different versions of Windows, it doesn't matter. It doesn't even matter how the version of the application is installed. Some of them could be layered on with app volumes. Some of them could be physically installed. Some of them could be on a physical laptop, for example. Whenever they run that version of the application, it'll pull back the settings from their settings layer. Every time a user makes a change within their session as well, backup configurations are made. And we even provide a self-service support tool so that if a user does something that they didn't want to do and they can't revert it, they can even go and revert the settings themselves back to a previous date in time. And we can manage all this through one simple interface. So this is the Dynamic Environment Manager GUI. And it enables you to stop using group policy tools and distributed scripts that you might have in Active Directory, for example. We can deliver all the group policies through Dynamic Environment Manager. So we've got some customers who've even stopped using group policy on physical laptops as well. And they use Dynamic Environment Manager across their virtual desktops and their physical desktops. And they've got a consistent experience across all of them. We can also apply all these settings and group policies in a more precise way. We don't have to do it like group policies do, where you're just a member of a particular OU, the policies get applied. We can actually target these based on conditions, and these conditions can change. So you could have a policy that's assigned to you and it only applies between the hours of 9 and 5. You could have a different policy that's applied to you out of hours. You could have a different policy that applies to you if you log on from home versus at work. So for example, you could be logged in at work and you could have cut and paste enabled, you could be allowed to print, you could be allowed to attach USB devices. But when you disconnect from that session and you go home, all those benefits are all removed. You can still log into your session, but you can't copy and paste, you can't print, you can't attach USB devices. And these can all be done with what we call triggered tasks. So for example, a log on and a disconnect and a reconnect can be a triggered task. So if I'm logged on at work and I disconnect and I go home and reconnect to the same session, the conditions can be reassessed, even though I haven't logged off and logged back on again. So it's really, really efficient and a really a good way to apply these settings. Let's move on and look at how the universal license looks. So the universal license, remember, has access to the cloud control plane, and it can be deployed on premises or in the cloud. This is the portable license. Now, if you deploy it on premises, you can still use the on-premises tools to manage it. You can also use the cloud control plane to manage it. And likewise, if you deploy it in the cloud, you can use the cloud tools to manage it, or you can use the cloud control plane. The code base of Horizon 8 for all these platforms is exactly the same, as long as it's the Horizon 8 platform. Whether it's public cloud or whether it's on premises, they all run on the VMware SDDC. And yeah, you can run them in any one of these public clouds, and you can also run it on premises. And it gives you that portability, remember that. So the cloud control plane includes a number of different features. The first thing it does is it checks and it validates you've got an active license. With some of these platforms, it can also automate the deployment of Horizon. It can also do the brokering of Horizon sessions for your end users. I'll show you that in a few seconds. It's also got a cloud monitoring service built into it, so you can use it to monitor the performance of your infrastructure and your desktops. And you can also use it to do your administration tasks. And remember that the Horizon Cloud Control Plane is what we can use for this hybrid approach. So you can connect a combination of public clouds instances to it, or on-premises instances to it. And you can mix and match them together. So if you want to, move things around and have half on-prem and half in the cloud, you can do that, and you can manage it and broker it all through the Horizon Cloud Control Plane. So an example of how the universal broker might work is that an end user might log in, they'll hit the universal broker, and unbeknownst to them, your organization might have some virtual desktops on premises, and they might have some virtual desktops running in VMware Cloud and AWS. And that end user doesn't really know where his desktop's going to be. Which desktop he's allocated is controlled by rules set by the administrator. So this rule could be something as simple as, connect me to the desktop I'm nearest to. And if that person's in the office, they'll get a desktop on premises. If that desktop was to go down though, the universal broker will redirect them to the failover site and it'll give them a desktop in VMware Cloud and AWS. As I mentioned, we also have a real-time monitoring solution built into the Horizon Cloud control plane. You can use this to do reporting and graphs and capacity planning, etc. The Horizon Daas platform, if you remember back at the beginning of this session, is the one that's partner managed. So partners manage these Horizon Daas platforms. You can go to the partner and you can engage with them. They will be able to also, as well as providing the Horizon solution, they'll be able to sell you some partner benefits layered on top of that as well. So in some cases, they'll fully manage all the updates and everything for you in some cases. That all, in this example of the Daas solution, it's all managed by the partner. All the infrastructure is managed by the partner, usually in the partner's data center, and it runs on the partner's cloud usually. Switching our attention to the Horizon Cloud on Azure solution, remember this is the solution that only runs on the native Azure platform. There's a lab for this on the Hands-On Labs. If anybody wants to do it, just go on to Google and search for VMware Hands-On Labs and put that code in. The Horizon Cloud on Azure solution is licensed and managed through the Horizon Cloud control plane. It runs on native Azure, as I said before. Now, it's still managed and controlled by the Horizon Cloud control plane. Indeed, the Horizon Cloud control plane totally automates the deployment of this solution as well. So all you do as an end user is you provide it with the details for your Azure tenant, you log into the control plane, tell it where the tenant is, click the deploy button, and it will fully install and configure the Horizon platform for you. Now, one of the questions we typically get is, what's the difference between Microsoft Windows Virtual Desktop versus Horizon Cloud and Azure? Because they both run on top of native Azure. Well, Windows Virtual Desktop has lots of benefits. It can run Windows 10 Enterprise desktops. It can run Windows 10 multi-session desktops, which and Azure is the only platform that supports multi-session. So think of this as a kind of RDSH shared desktop where you've got many users logging into a single desktop. But instead of doing it on a server operating system, it's doing it on a Windows 10 operating system. The WVD solution also supports long-term support for, or extended support, should I say, for Windows 7. And it also supports delivering apps and desktops from Windows Server. It also contains some benefits that are built into the WVD platform, such as using the Microsoft RDP protocol, being able to manage it through the GUI and PowerShell, some basic power management features, and some access to things like FSLogix. When you use Horizon Cloud on Azure instead, the first thing to point out is you don't need to set up WVD. All we need is an empty Microsoft Azure tenant with some networking configured. We install Horizon into it. We get all the same capabilities in terms of operating system use as WVD. We can still use long-term support for Windows 7. We can still use multi-session Windows 10. We get all the same benefits in that respect. We also add on lots of other capabilities though. So whereas Microsoft don't support Improvata, Horizon Cloud and Azure do. So if you're an Improvata customer, this could be a viable platform. We've got multi-factor authentication built in through some of the features that we showed you on the first session on day one. We've got the cloud monitoring service, which gives you the capability of looking at what's going on within these sessions. We can do hybrid approaches to VDI, whereas WVD is just Azure. We can integrate Horizon Cloud and Azure into the Workspace with access and the application catalog that I showed you on the first day. We can do universal brokering between different hybrid cloud environments. We've got access to different protocols, such as our Blast Extreme and PC over IP protocol, which with them brings additional benefits. We've got application layering with app volumes that we've already talked about. We've got Dynamic Environment Manager, which does that settings abstraction. We've also got advanced power management, which can actually save you a ton of money. If you're using your Azure tenant in pay-as-you-go mode, then by leaving your desktops logged in overnight when they're only used 9 to 5, you're paying for them all through the night. With our advanced power management features, we can set complex rules about when machines are powered down, how many machines are left in standby, you know, a reduced kind of service for emergencies, for example. And we can control all this through the power management features. Because we're not restricted to the RDP protocol as well, we're using a combination of RDP, Blast Extreme, PCRP. We got much broader client support. And we can do all these common, you know, GUI management tasks from this single platform. So lots and lots of benefits to using Horizon Cloud and Azure over native WVD or Windows Virtual Desktop. And just to kind of wrap up this session, we'll talk you through some enterprise features that are also within the platform. So, you know, it's a very, very feature-rich, very mature platform. Horizon's been around a long time. We've been building various use cases that are in use today. So lots of people use it for advanced 3D graphics. We have lots of engineering companies, car designers, people like that using it. We've got people in hospitals using it with, you know, digital dictation devices. You know, we've got lots and lots of peripheral support for things like printers. We've got full support for things like Microsoft Teams, so all the collaboration software supported. Lots of other collaboration software vendors made their own plugins for it, so things like WebEx and tools like that. So there are lots and lots of things and use cases that you can use Horizon for. It's not just simply logging onto a desktop and using Office anymore. We also have some additional functionality built into it, things like session collaboration. So with session collaboration, you're able to do some quite cool things. So you can actually, when you're logged onto your virtual desktop, you can actually launch a session. And you can, once you're in that session, you might want to collaborate with a colleague. By clicking the session collaboration button, you can initiate another colleague to join your session. So you can type in that user's name or their email address, and you can invite them by a number of different means. One of those is email. And when you click on the email button, what it will do is it'll automatically populate an email for you with the link for that user. When you send that email to that user, that end user will receive that email and they'll open it up, click on the link, it'll ask them to log in, and they will be logged into the same Horizon session as user one. Now, some of you are probably thinking, well, I can already do that with Teams and I can already do that with Zoom. Yes, you can, but if you want real-time collaboration, this is far better. You've got to remember that all those sessions in Zoom and Teams are bouncing up and down to the cloud. With this session collaboration tool, all your users are connecting into the same stream, so there's no delay. So when your end users start moving things around on the screen, the user one will see it at exactly the same time as user two. And we can also extend this out and be able to get like a third user to be able to join using the web browser. So we can invite a third user and they might be on a device that doesn't have the Horizon client installed. We can also pass control backwards and forwards between all these users. And we've seen use cases for this, like in hospitals. We've got some hospitals that use this to share and get second opinions on images, etc. We've also got some people in education that are using this for teaching purposes. This is all built into the Horizon platform. You see how there's no delay between user one and user two? That's because they're both connecting to the same stream. There's no delay with it being the signal being bounced up and down to the cloud. We also have things like a help desk tool built into the management console. Now, don't think of this as a call login system. This is a help desk tool to try and diagnose problems. So what you can do with this is you can log in, you can search for an end user that might call up, and you can look at all the metrics and all the details around their session. You can look at all the client details, all the details about what machine they're connecting from. You can look at all the details around the machine they're connected into, so the VM details. You can look at all the details around the host that VM's running on. You get a bunch of commands about being able to, you know, remote assist them, being able to restart their session, etc. And you can even see what components made up their login time. So if a user calls up and says, my login took 5 minutes today, you can quickly and easily diagnose what took all that time in the login. So it's a really useful tool. And as of last year, we can now publish applications, not just in a Windows Server session, we can actually publish them from a Windows 10 session as well. So if you wanted to be able to publish just an application and it never ran on Windows Server, you can now publish it through Windows 10. Also, if you ever wanted to publish a UWP application which don't run on Windows Server, you can now publish those as well. And this also means that you can publish desktops and applications to your users without the need for an RDS farm. So you don't need to have a server farm to be able to publish applications anymore. You can simply use your desktop farm. So you need less infrastructure to be able to do this. Let's end the slides now. Let's jump across and do a demo. So what I'm going to show you first is the logon experience for Horizon. So here I've launched the Horizon client, and you'll see that I can also connect to this through a web browser. When I connect to a web browser, it gives me the option to download the client, or I can simply carry on and I can log in to the web version. And you'll see that it asks me for my username and password. We can put two-factor on here as well if you wanted to, but when I log in, you'll see that it shows me what I'm entitled to. So I can change my settings, etc. But I get a bunch of desktops I'm entitled to, and I might get a bunch of applications I'm entitled to. Some of these might be running on Windows Server, some might be running on Windows 10. The end user doesn't need to be concerned. If I log in through the Horizon client, you'll see that the experience is largely exactly the same. So the end user signs in, they get exactly the same entitlements, just in a slightly different view. Now I'm going to log into a Windows 10 desktop, and I'm going to show you how fast the application layering happens without volumes. So I'm just going to initiate this logon. And this is actually logging on to a Windows 10 session that is based in the US as well. So just so you get an idea of how good this is, how good our protocols are with this long distance latency as well. So I'm now logged on to a Windows 10 desktop in the US. And what I'm going to do is, although app volume layering normally occurs during the logon process, so in a typical environment, by the time my desktop's usable, the apps would already be there. In this scenario, I'm going to run a script that simulates attaching some app stacks in real time. And I'm going to show you by means of like visual representation of icons on the desktop. So what this is going to do is I'm going to run a script to enable lots of apps. It's going to send a command to app volumes to attach me some app stacks. And within a few seconds, a bunch of applications are going to be installed on my machine. And when those applications are installed on my machine, they will deliver all the icons on the desktop. Oh, there we go. Yeah. So you can see all these icons have been delivered, but these are actually fully installed applications already. So I can actually launch any of these. I'm not too sure what's happened to my desktop icons there. So I can run any of these. So they're actually they aren't actually just icons. There are actually applications behind them. Yeah. So here's one that I've just installed. And as you can see, I could go and run any of these, and they'll run and they'll behave as if they were installed locally. So I don't have any latency going off and trying to like cache the application as I'm loading it. I don't have any delays in the applications being attached because the network's busy. I can simply go and I can run any of these applications once they're attached. So with that, I think I'm just about on time. I'm going to stop. I'm going to end the sharing, and we'll take some questions. I guess I'll hand back to Neil and Stuart.
Thanks for the presentation, Darren. It's great to see that VMware can enable a scalable, secure desktop environment, as we've seen today. And as we've been throughout this week, if you have any questions, please do drop those into the Q&A or chat box. We have been monitoring throughout the session anyway, and I do have a couple of questions that I saw earlier and another one that's come through on the chat box. So first of all, I'll ask the question, my company use Microsoft Teams and other collaboration tools extensively. I'm worried about what the audio and video experience will be like.
A good question. That's something that we get asked a lot right now. With so many people working at home, lots of people are having to collaborate remotely. We have in Horizon 8 something called Teams optimization. And what that does is it means that even though you're on a VDI machine and your desktop's running in the data center, your audio and video is redirected directly from your endpoint to your destination. So there's no hairpinning of traffic, we refer to it as. All your audio and video is not going into your VDI machine and then going to its destination. It's going straight from your endpoint. So if you're at home, for example, on your PC, and you're logged into a VDI machine and you initiate a Teams chat or a Teams video with a colleague, and they're also at home, your audio and video will go point to point between your houses. It won't go via the VDI machine. So you don't need to worry too much about latency, and you don't need to worry too much about audio and video quality.
Yeah, that's great to hear. I think we all can concur that we've become very dependent on video calls, such as Microsoft Teams. So it's great that VMware are working hard to enable this. Another question we have, this time on licensing. We've got someone on the call who said they are an existing Horizon on-premises customer, and they want to know if there's an upgrade path to Horizon Universal, or do they have to purchase again?
No, there is an upgrade path. Yep, there's an upgrade path. That license actually starts on February the 4th. So like in about a week's time, you'll be able to upgrade that.
That's great. So, so a question that came through on JMP from the slide earlier. So on JMP, what layers are transferred via network, and what is stored on the hard drive?
So the hard drive essentially only contains the operating system. The application layers are not transferred over the network. They are on VMDK virtual hard disks, so they are attached, they're not transferred. The only data which is transferred over the network is the settings layer, and that is typically really small. We're transferring like 1K files over the network for the for typical settings. So we're talking a tiny amount of data.
Okay, brilliant. Thanks, Darren. Another question, what are the minimal system and network requirements to provide optimal service? Most of my colleagues have poor internet connection.
That's a good question. So the good thing about our protocols is that they're designed to work in really high latency, poor bandwidth environments. So I can't off the top of my head remember what the lowest bandwidth is, but in terms of latency, I think we can work right up to about 180 milliseconds of latency, which is quite high. You could access a desktop on the other side of the world and have less than 180 milliseconds of latency.
Yeah, can I come in there as well? So we've done a lot of testing on this over the years. I've been fortunate enough to be involved in it, and we've actually seen desktops being used over anything up to 400 milliseconds out into South Africa and out into Asia. I guess the question comes back is, what are these users doing? What kind of applications are they launching? Are they running graphics? It's that it depends scenario. So Neil, Stuart, I think it'd be a good one to follow up on, just to understand what the users are actually accessing from home, what sort of bandwidth. I've always lived in a low bandwidth area. Fortunately, BT came in last year and surprised me with fiber. But I used to have 3 megabytes of bandwidth, and I could run a desktop session out of our cloud in Amsterdam. Run standard applications, run YouTube within the session, and I've rarely got any issues. So it will depend on what the users are doing.
Yeah, thanks, Paul. One thing that I've just thought of actually is that before pandemic, when I used to go around and do demos and things for customers, I used to always do my demos off my mobile phone. So I would be using 4G and in some cases 3G, and you can run a desktop even over 3G. So that'll give you an indication of how low the bandwidth usage is. Just remember, it's only sending screen updates through the protocols and they're compressed. And in some cases, the protocol's so efficient now, it's not even sending whole screen updates. If you just move your mouse, it's only sending changed pixels. So it's really efficient, really compressed image it's sending.
That's great. It's a really detailed answer, and I think right now, I think we can all again concur that end user internet experience might not be the best, but of course at Kuiper we can talk to you about that as well. So that might be certainly one we would like to follow up on following this. And looks like one more question has just come through. What benefits does Blast Extreme provide for the end user?
So do you know what? The end user shouldn't really care about the protocol, but the one benefit I would say that they won't see but they'll get is that Blast Extreme uses H.264, H.265, which, if you know about codecs, is the same codec that's used by Netflix and people like that. And it uses, for its decoding, it uses the native GPU in a device. So I would say the main benefit to an end user is device support, because any device that's got a GPU, which is practically anything nowadays, will be able to efficiently decode that stream from Blast Extreme. What that also means is that because the GPU is doing the decoding and not the CPU, it'll improve the battery life. Now, again, I go back to the end user's not going to really know, but their battery might last longer in their device. That's what I would say.
Fantastic. Okay, it doesn't look like we have any more questions through, so thank you so much for those questions today, and it's great to see there's so much engagement with this particular topic. Handing back to Stuart to find out what you thought of today's session. Stuart.
Nice one, cheers Neil. Yeah, thanks chaps, brilliant feedback there. So we really do want to go above and beyond for you. So it's essential that everything we talk about appeals and relates to your personal challenges. So I'd now very much like to understand whether today's content answered the questions successfully. A quick survey now, and you can place your answers using the polling buttons that you should now be able to see on screen. If you can't, as always, you can pop your answers in the chat. So the big question today is, how confident do you feel that VMware could help you to prevent end users taking unnecessary risks? The choices are very, somewhat, and that you still need persuading. So if you could please submit your responses, and we'll let the Zoom machine calculate the result. Everyone's smashing buttons now. Give it another couple of seconds, I think. Okay. Okay, right then, here we go then. So 56% of you are very, so we've obviously nailed it for you guys. That's fab, just what we wanted. 44% said somewhat. So that's good to see, but we know what we need to do to work on you a little bit more, I think, there. And none of you need persuading, so no bribery needed with the full English breakfast, so that's fantastic. Thanks ever so much for that feedback. Really appreciate that. That's the poll closed. So as I mentioned then at the beginning of this session, this is day 3. Yesterday we looked at how we can better manage the escalating number of endpoints. And on Tuesday, when our series began, it was the topic of the importance of seamless employee experience. So tomorrow, it's our final day of the Big Breakfast webinar series, but it sees us examining how to better secure the enterprise by condensing dozens of solutions down to one. If you've not registered for tomorrow's session and you'd like to, drop me a line and we'll make sure we get you a link sent out. Again, we're also making these sessions available on demand, so you'll be receiving information on how you can access the recordings if you can't attend in person. I'd like to extend my thanks to you all today for joining us, and to our speakers, Paul and Darren, for illustrating how making Windows apps available for every user on any device reduces the headache for IT and the risk for your business. To finish off, we'd like to leave the final words with our customers. Here are some of the quotes that I believe highlight how Kuiper serve you and go above and beyond. We'd love to have the opportunity to do the same for you. Over the next few days now that we're getting away from the roller coaster of 2020, we'll be approaching you for some feedback and identifying ways we can work together to strengthen and adapt our businesses for the future. If there's anything that the team or I can do for you, please reach out to us at any time. So from everyone at VMware and Kuiper, we really appreciate you taking time out of your day to join us. Thanks again and have a great rest of your day.